Welcome everybody back to the 46th episode of the Swift and SwiftUI Learn Along. Today marks a milestone because it is the first day of the SwiftUI compendium, which is just the name of a course that's hopefully going to teach us SwiftUI. So I don't necessarily know what to expect because this is just from some random guy selling a course on Gumroad. So hopefully it's good. But I guess this can serve as a review of sorts. But yeah, we'll see. We'll see how it goes. So this is it here. I suppose if it's good, then that's good marketing, right? Then we can recommend it. So yeah, that's what we're gonna do. Same with the Big Nerd Ranch guide. So I guess I should start with the. Jared's looking at me like, yeah, do it. Okay. So for the uninitiated, I'll keep it brief. But on this stream, I am learning Swift and SwiftUI in real time on stream. So I don't do anything off stream. Done it all on stream. Learning it for the first time. So you're more of a fly on the wall as I narrate the book to you, learn it myself, and then hopefully by virtue of that, you can learn along with me. But that's the general consensus. So it's not like an interactive thing. I'm really trying to learn it, starting a company, and fully intend to build the first product that we won't talk about much today. But we are going to build it on the stream. So all of this is in an effort to actually build a thing, not just kind of throw out programming content, although that's cool too, brother, but that's not what this is. So if that jives with you, then make sure you follow and all that jazz. But otherwise, we're just going to get started. So yeah, this, like I said, this is the SwiftUI Compendium, which is a course from, let me give credit where credit is due. Maybe. Just so you can, or let me just show you the website, actually, that's probably better. Duh. iosfoundations.com. Okay, so that is the credit for the educational resource here. I already downloaded the Xcode project, so there's a sample project. Let's see, what are some qualifiers here? He's saying we're not going to go too deep into the examples, but given we've only had one taste of SwiftUI for the singular chapter from the Big Nerd Ranch guide, yeah, I mean, we'll just dig into it. I don't know. You never know what you're gonna get, but either way, it was reasonable, so it was $30. And the thing that attracted me to it was that it focuses on how to look things up in the Apple documentation, and all of the things that it's teaching directly reference the Apple documentation. So his assertion is that he's teaching us how to sift through the docs and use the docs to come up with solutions, which I like that because ultimately I find that's, especially if you're using newer technologies, that's where you end up, is the docs anyway. You know, there's not going to be a ton of, you can't always assume there's going to be a lot of content out there showing you how to do the thing that you're trying to do. Maybe it hadn't been done yet, you know what I mean? So that resonated with me, so hopefully that pulls through. But that's the general theme here. And then after we work through this, as I've said before, just so you know what to expect, we're going to do a couple of days of schema design. So for the local SQLite aspect of the application, and then also we'll probably end up using either GraphQL or just your standard REST API, or rather JSON API. But either way, we're going to do some design there for the application itself. So for the local onboard storage, and then also for the web server. And then after that, we're going to roll back into another Big Nerd Ranch guide on iOS programming, macOS programming. So all the Apple specific platforms, which is their recommended follow-up to the book that we just worked through. So we've already worked through the entire Big Nerd Ranch guide, 7th edition, on Swift as a general purpose programming language, which was great. It was a great insight. I like Swift a lot, so I'm excited for this. After we go through that second book, we would have then covered the full gambit, at least in terms of, you know, educational material, touching on all the things that are possible. And then we'll just start hacking away and building the thing. Okay, so that's the plan, and now the show begins, brother. Okay, so I'm not going to read this. I read through this a little earlier. Do not merely read the code samples. We don't do that here anyway, so I agree with that. So this is just qualifiers and not stuff that's valuable. So let's move on. So the types of documentation offered by Apple. Over time, Apple has amassed a wealth of information regarding app development for its platforms. Unfortunately, this information is scattered across various sources. In this course, I'll utilize various primary resources detailed below. Given the extensive documentation, I don't anticipate you reading all the guides I will link to below. This list serves as a reference. Throughout the course, I'll specify the sections to read and their order. Okay, good. Oh, that's nice. The Swift language guide to create SwiftUI apps. Actually, I'm going to save. Oh, I don't need to do that. Never mind. But I will send these to the board that I'm going to share with you guys, where we've been saving just all the stuff that we've covered in detail. So capture. Yes, I want to do that. Okay. All right. To create SwiftUI apps, a basic familiarity with programming in Swift is necessary. This course won't cover programming basics, but assumes you are acquainted with fundamental programming concepts, and we are now. However, SwiftUI utilizes several advanced Swift features, and even seasoned developers might not have mastered these features yet. Fortunately, SwiftUI embraces progressive disclosure, leveraging the advanced Swift language features to provide a straightforward and intuitive syntax. This enables even beginners to create iOS apps. Okay. Still, a basic understanding of these concepts is needed to navigate the SwiftUI documentation. I'll provide links to specific sections in the Swift language guide when required. All right, I'm going to save this. Yeah, Board Mix, by the way, awesome app. I have no affiliation. I just a user, but it has the best web clipper known to man. It's so awesome. I mean, you can send text directly there. You can send URLs. You can drag and drop. You know, if you just want to drop it here, you can send images. You can clip pages, scrolling. It's just really damn good. This is the bar to me for web extender, or what do you call them? Web extensions, yeah. Chrome extension. I'm used to calling them Chrome extensions, but it's Edge extensions. Anyway, Apple's documentation available. Wait, I skipped something. The Human Interface Guidelines. These guidelines offer an overview of Apple's platforms, components, patterns, and technologies. These, okay. Though not mandatory, these guidelines provide essential context on how interfaces are intended to work on different Apple platforms. Oh, yeah. I'm just going to open that in a separate tab. I kind of want to go look at that. Apple's technical documentation. Apple's documentation available online and within Xcode contains crucial information about Apple's frameworks and tools. It covers all available APIs and their intended usage. Moreover, it includes several articles showing specific topics and examples. Okay. Primarily, we'll utilize the documentation for the SwiftUI framework. I will also save this. What did it say? I'm not logged in. Like hell, I'm not. What do you mean, brother? No, I guess I got to do that. Okay. Yeah, see, they're still doing that deal. I think it's a pretty good deal, but I'm not a sales guy for them, so I'm just going to log in and do my shit. And oh no, this is mine. Okay, I didn't recognize it at first. Okay, so now can I do that there? Cool. And then I guess it didn't save this one, but there we go. All right. Apple's technical. Primarily, we'll utilize the documentation for the SwiftUI framework, since developing SwiftUI apps requires using Xcode, the Swift framework, and types provided by the Foundation and Observation framework. I will also reference their documentation. Okay. Yeah, so let's just... I think I had all these, but it's all good. This will all go on the board anyway, so WWDC session videos. Oh, gotcha. Worldwide. Is that what that means? Yeah. Developers Conference. Apple conducts sessions annually at the Worldwide Developers Conference, offering a wealth of information. These videos contextualize and explain the usage of new technologies. Yeah, if you haven't watched the one on SwiftUI, I actually think so, because sometimes these are kind of hammed up. It's like it's a whole lot of nothing burger. You know, um, but let me show you. Actually, it's probably a while back, so it'd probably be WDC Swift. There was one, I think it was the initial one. Yeah. Oh, hey, look, I'm live. 4 years ago. I think this is the one. Come watch this one if you just kind of want to get the backdrop, the history, why they did it, similarities, all condensed into a that can't be a 7-minute video. Oh no, it's an hour. That's 7 minutes left. Yeah. So SwiftUI Essentials. This is actually, I'll save that one to you, brother. I'm pretty sure that's the one. Yeah. But yeah, the presenter does a really good job of explaining more or less the same thing we covered yesterday, but with way better visuals, like for presentation purposes, obviously, compared to my squiggly lines and blobs of code. So go check that out if you want to know a little bit more about the SwiftUI in the large. Okay, Apple conducts sessions annually at Worldwide Developer Conference. Oh, I read that. You can browse all the sessions online or access them through the Apple Developer app. Oh, cool. I didn't know there was a... Oh, wait, yeah, I did. I had to download it for this Apple Dev thing. To give them money to be an Apple Dev, $100 a year. It's actually surprisingly cheap, given that it's Apple, but it's still more than free. Back to accessing the SwiftUI documentation from within Xcode. Okay, so now we're... Oh, it's just slow. Okay. Accessing the SwiftUI documentation from within Xcode. Throughout this course, all links will direct you to online web pages. However, Xcode allows you to access the documentation for Apple frameworks from within its interface. Yeah, we did cover this, so the big nerd thingamabob did show us this. So I'm going to skip by here. Sometimes it doesn't work. I think it's more of an Xcode thing, not available thing. The sidebar showcases all Apple frameworks, including SwiftUI. Click on a framework to explore its content. Yeah, so there's a crazy amount of frameworks. So Xcode is open here. And if we... So just under the help menu, dev docs. Look at all these frameworks, isn't that wild? Accessibility, Activity Kit, Analytic Reports, App Clips, App License, SDK, App Kit, Browser Engine Core, Browser Engine Kit, Bundle Resources, Compositor, Core Foundation, Distributed Foundation. Buddy. It's a lot. Yeah. Okay, so let's go back then. While the sidebar is a primary exploration spot, the navigation bar also provides... Can I make this, fill this page out a little bit? Let me see if it's... There we go. Gee, what zoom is that? 200. Okay, the sidebar showcases all Apple frameworks, including SwiftUI. Click on a framework to explore its content or reveal it by clicking the disclosure indicator. Yeah, so you go to a board, any image, it just gives you that little button. You can just send it there. It's so good. While the sidebar is a primary exploration spot, the navigation bar also provides drill down menus containing all listed entries of a documentation page. Okay. Apple's documentation might not be ideally structured for learning. For instance, SwiftUI's initial documentation section covers throws having a weird. Swift's initial documentation section covers app structure, which might not be the most beginner-friendly starting point. I really disagree with that. However, this structure allows for a quick overview of all documentation and proves helpful when searching for specific info. Yeah, it's funny he says that because honestly, for me as a beginner, that's been one of the most, like in other programming languages, one of the first things I look for is like, how do I start an actual project? You know, I mean, if you don't know how to structure the apps, you can learn syntax all day, but it's never gonna, you can't make anything happen, you know, on the screen. Nothing will build so cool if you know syntax, but if you don't know how to structure the app, um, you're kind of lost. You're useless. You know what I mean? But yeah, that's an interesting take. Searching the documentation for a specific symbol. The documentation window includes a search field at the top where you can look for types or methods. Okay. Oh, that's part of that. However, I find this method often lacking. For example, searching for SwiftUI's frame view modifier will yield anything but the correct result. That's true. I did hard agree with that. You search for something and it's like almost never what you see, but like a trillion other things related to it. The search field can also be unresponsive, failing to show results as you type. A more effective way to find documentation for a particular symbol is to utilize the search bar, the search filter at the bottom of the sidebar. Okay. Well, that's good. That's good to know. Let me see. Search bar down here. It's so tiny, I never even seen it. It's way down there. If, get my little pointer out. Where is my, oh, there it is. Red. Yeah, so way down here. If you can see that, that's what he's talking about. Which I never knew was there, but now I do. So let's see, what's something I was looking for the other day? Oh, how about some? Or no, how about opaque? Opaque type. It's just kind of dookie all around. Like, I hate to say that, but like I search for opaque type, you would think to some degree I would see, maybe this isn't the right spot, but you know, protocols and like how it works, what it is, like just the definition of the term itself. Instead, I get these. Yeah, no, I don't think. Maybe that's because these are only. These must only be frameworks and not the language itself. That has to be why. Otherwise, it doesn't really. I guess it kind of says that too, but I mean, there's fundamentals here: number, data, strings. Resources. Yeah, I don't know. It just still doesn't seem to really. Yeah, because there's a whole bunch of other stuff. Networking. And here's Swift itself. But I wonder if it only filters on what you have clicked. Maybe that's why. Okay, I might be getting somewhere. Opaque pointer. Okay, I mean, this is a little better. So I guess that was part of my problem, maybe. if it's context sensitive. I thought it was just searching everything always, because it doesn't really say otherwise. But okay, so that's good to know. So it's a option, but yeah. Type the framework name first to filter results, then enter the symbol name to see. Oh, okay, I didn't do it right. Okay, then let's try that. Okay, Swift. Oh, you first have to apply it and then, okay, now how about, okay, opaque. Oh, but wait, that's not, okay, I'm not, that's part of Swift, not really Swift UI, even though they use them. So is just Swift a filter here? It is. Weird they call it a framework, but okay, so now opaque. Let's see, interrupt. Opaque type. Whack, bro. Okay, whatever. Not worth the time. Okay, so accessing a symbol's documentation directly from within the editor. Another access point of documentation is the Xcode editor. You can click on any symbol. Yeah, we saw that, so I'm not going to dig on that. The panel is also accessible on the right-hand side. We also saw that. That is nice. I mean, that's honestly probably the best method, I think, if it populates. Open in developer opens the link. Okay, but that's the same content, so that's good to know. The side panel and the full window, the thing we're just looking at, this thing. I'm going to close this, though, since it's not very helpful. All right, what else do you got, brother? All right, getting started with Apple's SwiftUI tutorials and sample apps. Since you enrolled in this course, chances are you're just beginning your journey in SwiftUI. However, some students have taken this course seeking an overview of SwiftUI, even though they're already familiar with creating apps. Before delving into SwiftUI, I recommend a guide that is beneficial for everyone. The API Design Guidelines, available on the Swift website. Capture, yeah. Wait, what? You want me to read that first? Available on... Nah, we don't need to do that. These guidelines are an excellent starting point for crafting Swift and SwiftUI code that seamlessly fits Apple platforms. Maybe we might go back, but yeah, we'll see. We'll see how it starts. Not feeling great about it so far. Honestly, only because this tool I showed you guys yesterday, the Interact Full, and just how fully fleshed out it is, we might just hop over there, but we'll give it a shot. Subsequently, for beginners in SwiftUI, I suggest following Apple's basic tutorials. Despite their slightly scattered approach, these tutorials offer an initial look at the available features and provide guidance on writing fundamental Swift code. By the way, I'll try to be less contentious with when I'm reading this stuff, because the guy that sold the course, I mean, I'm making the assumption he's telling the truth, but he's been doing it for a decade, according to him. So I'm going to trust that that is true and try to contend less with it. Okay, so at the very least, I recommend starting with the Develop in Swift tutorials, especially if you're relatively new to app development and specifically to SwiftUI. They offer a quick overview of the most common SwiftUI aspects and acquaint you with basic Xcode functionality. And we'll skip that only because, although I will save the link, we just did something similar with the Big Nerd Ranch. We did that whole example chapter on SwiftUI. Following this, the The Introducing SwiftUI and Learning SwiftUI tutorials reinforce these basic concepts while introducing a few additional ones. Okay, go ahead and hobgob all these links here. It's worth noting that while these tutorials cover a range of concepts, they do so superficially and in a scattered manner. I have the hiccups. You must refer to Apple's documentation, as I'll demonstrate in this course, for a deeper understanding. Apple also offers several sample apps catering to various tasks, from navigation and user interface layout to accessing device sensors, capturing photos, and delving into machine learning. Yeah. Which, by the way, just so it's said, already, I mean, he's just listing out the stuff Apple makes available to you, not necessarily his course yet, but already, I mean, that is a lot more than you're getting with a lot of other languages. Not necessarily a knock on them, but just saying, to have this kind of information, this amount of examples provided for you, scattered or not, that's it's a win for sure, and it matters. Okay, we will look at those in order during this course. You should remember these as a reference when looking for a solution to some specific problem. Okay, so let's save that to exploring sample apps. That will be handy. Boom, 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 boom. The levels of abstraction. Yeah. The levels of abstraction used by SwiftUI. SwiftUI is a powerful framework. To achieve its capability and versatility, it incorporates nearly every feature of the Swift language. In fact, some of these features were specifically developed by Apple in secret to enable SwiftUI. Really? Really? For beginners, this complexity might pose some challenges. However, thanks to progressive disclosure, one can embark. For example, this complexity might pose some challenges. Oh, for beginners, not okay. For beginners, this complexity might pose some challenges. However, thanks to progressive disclosure, one can embark on the basic tutorials I linked in the previous module without having to understand these advanced concepts, which we should be all set, brother, because we already done covered like literally everything, big nerd style. However, these features occasionally surface while exploring the SwiftUI documentation. Fortunately, using SwiftUI demands only a surface level grasp of these concepts. A deep understanding is only required to fully leverage these features in complex codebases. The Swift language provides increasingly complex levels of abstraction. Yes, it does. We know that all too well. Every Swift feature offers increasing levels of abstraction, allowing a developer to... okay, hold on. This is a refresher. Where's the content, brother? Let's just get going. Level 0, concrete code. The ground level of abstraction is concrete imperative Swift code that executes the desired instructions. Imperative, by the way, just means like literal, do this, and then this, then that, from a top-down style, just like that command line tool we wrote. If you hear something, or you'll often hear of imperative, also referred to as procedural code versus declarative. So like SQL is a good example. That's declarative. You're literally just saying, describing what you want, but you're not having to tell the system how to go about doing it. Whereas, you know, in Swift, when we write it, like, where's my, just as a quick example here. It's like SQL, you're just saying select, and then, you know, you name your fields, comma separated, and then you do from is the other keyword. So from, and then your data table, and then where, where, and then, you know field field 1 is greater than field 2, you know, whatever your conditions are, but it's really simple. So you're just literally describing, like, I want this data, you know, these columns from this source where these conditions are met, and then it just spits out the, you know, that's declarative. Procedural is like the code that we've been writing, where we're having to tell the system not only what we want, but we're training it on how to do it and in what order. We're telling it, go to this, you know, pull this function in from that framework, go read this file, encode the entire file. You know, we're having to do every single step. So that's That is the difference. And often a trade-off between, the kind of control you have over performance and the expressiveness versus how easy is it to just write and do the job. But, SQL is always going to be the winner. But yeah. However, it is not mandatory to, wait, where was I? Concrete code. Just kind of try to code. Yeah. The ground level of abstraction is concrete imperative Swift code that executes the desired instructions. This level encompasses the building blocks of every Swift program, such as integers, floating point numbers, Boolean strings, collections, constants and variables, tuples, basic operators, optionals, control flow statements. The good thing is we know what all of these are, so that's good. Level 1, functions. The first genuine level of abstraction is introduced by functions, which enable code reuse with different values, or, at the very least, help you organize your code in discrete segments. Okay? So the first level is functions. Higher order functions. However, function types and the higher order functions they enable are advanced concepts. A higher order function is a function that takes other functions as parameters or returns a function instead of a value. Yeah, we did touch on those. We'll use them, although I don't think I think probably reading the syntax is more complicated than understanding the concept itself, because we do this a lot. Probably just even through spreadsheets, you would understand this from a conceptual point of view. Meaning, if a function takes two arguments, A and B, but A is something you also need to calculate, so it's not just a hard value. That would just mean passing it a function instead of a concrete value. But yeah, I think most people kind of grasp that. Nevertheless, function types play a crucial role in SwiftUI, as we'll explore later, especially with closures. Yeah, boy, closures, yeah. Level 2, custom types. At the subsequent level of abstraction, we encounter custom types like enum, structures, and classes, which we covered in droves, with initialization, properties, methods, and subscripts. Custom types can group data and their associated code. I'm curious, I know what those are, but the subscripts, is that the same as subscript index int? Wait, what? Classes, structures, and enums can define subscripts, which are shortcuts for accessing the member elements of a collection, list, or sequence. You can use subscripts to set and retrieve values by index without needing separate methods for setting and retrieval. Okay, for example, you access elements in an array instance as some array index and elements in a dictionary instance as some dictionary key. You can define multiple subscripts for a single type. And the appropriate subscript overload to use is selected based on the type of index value you pass to the subscript. Oh, okay. So it's like pattern matching. I mean, okay. I mean, I get it, but I can see why these didn't really stick in my mind, because I like having the separate methods. I think it's just cleaner. I don't like overloading, honestly. I like that it's there, but I wouldn't want to reach for that. But anyway, so let's go back to. Oh, whoops. Damn it, where was I? There we go. Custom types serve as a cornerstone in SwiftUI. While my SwiftUI Structural Foundation course delves into the best practices for distributing code across custom types, for this course's scope, simply consider custom types as a convenient way to group related code. Yeah. Wait, you tell me they're so cheap, so I just want to see where this one should land ahead or after the one that we're currently doing. For well-structured. Actually, we don't need to do, yeah, because we have the whole big nerd book coming, and they will not skimp on detail. Okay, so we'll just stick with SwiftUI. For this course's scope, simply consider, oh yeah, we read that. Property wrappers. I'm going to skip past stuff we've already read about and learned about for sure, and that one is a for sure one. Level 3, inheritance and protocols. Yeah, because if nothing, I mean, the way he's describing it is more or less helpful if you didn't know the language, but we're going to know what we're looking at, so I'm not going to feel the need to type along. Oh, that's just some random guy that, okay. This always cracks me up, like when people, like I feel like the dude that wrote this, piece of the article, the course creator, he wrote all this, it's well laid out, makes sense, and then someone will come along and restate something as though it's a new statement. I don't know, maybe that's a language barrier thing, but I don't know, that whenever I see that, I'm like, okay, but hey, reiteration isn't necessarily a bad thing. There are no published lessons in this course yet. What? I'm just going to ignore that, but that's weird. WordPress, goddamn. Throughout this course, we will implement a groceries app that allows the user to buy groceries online. The first step in building a SwiftUI app is to create a new Xcode project. You've probably done so already, especially if you followed Apple's SwiftUI tutorials. The creating an Xcode project for an app section of the Xcode docs explain the processing in more detail. Any new SwiftUI project comes with the following template code. Yep, yeah, we saw that yesterday. This is where we will start looking at the SwiftUI framework documentation. Okay. The SwiftUI documentation begins with the app structure topic. However, as previously mentioned, that might not be the optimal starting point for learning app creation. While the app structure forms the starting point of a SwiftUI app, interacting with this structure is infrequent. Most of your code will primarily consist of views, the core around which all of the concepts revolve. Yeah, I wonder if, and this is probably going to do a good job of it, but if nothing else, I want to get, what I really would like to get is even if I have to make it myself, it's not like it'll be too complicated, but just a visual representation of how the views work, because we already know it's very similar to HTML elements, which is a big head start. So if we just had a visual, like a one-pager showing the different rules, like let me look for it real quick. There's a really good Vue.js one-pager cheat sheet. I don't know if it'll pop up, but if I can find it, it's what I would like to mimic for Swift, and we can create it. It's oh, maybe it's this. Yeah, this thing. So check, yeah, any of these would work. What the heck? Come on, brother. Can I just look at the, okay, I think it'll let me. Well, it's all blurry, but you can see, the different headings. So just the main topics, and then little small syntax examples beneath. And there's you can see the little arrows that point to other code examples, but it's showing you how they connect to each other, which is, at least for when you're talking about writing interfaces, visual interfaces, graphical interfaces, I think that's wildly helpful. So we'll look to do something like that if this course doesn't provide it. Because I'm going to have, for HTML, CSS, when I was learning that, more or less, I would always have that up on my iPad, just the one-page cheat sheet, and that's a super big help. All right, so therefore, the most suitable starting point is the view topic. Specifically, your initial step should be the view fundamentals section. Yet, I advise against merely reading through the content of this page in sequence. Instead, begin your journey by delving into the declaring a custom view article, reinforcing the foundational concepts you've likely absorbed. Let's save these. You've likely absorbed passively from the SwiftUI tutorials mentioned in the previous module. As a general rule, when I link entire sections as I did above, I do not expect you to read them in their entirety. Instead, I will link to specific articles or symbols. As a general rule, when I link to, okay. Within these pages, you will find multiple links to other sections in Apple's documentation. For the duration of this course, I suggest refraining from following these links as they often lead to never-ending, out-of-order tangents. Exactly. Yeah, they definitely do. We will systematically cover the relevant guides as we progress. Okay. So table of contents. So this is cool. I like where this is going. Okay, the view protocol and its associated type. After reading the article and looking at the Xcode template code, you can see that declaring, oh wait, so okay, it wants me to go, specifically your initial step should be the view fundamentals section. Okay, so we're gonna go read that. View fundamentals. Just that, okay, just that part? Literally just that, all right. Said not to click around, so we will not. All right, view fundamentals. Define the visual elements of your app using using a hierarchy of views. Overview. Views are the building blocks that you use to declare your app's user interface. Yeah. User interface. Each view contains a description of what to display for a given state. Each view contains a description of what to display for a given state. Every bit of your app that is visible to the user derives from the description in a view. Okay. And any type that conforms to the view protocol can act as a view in your app. Yeah, you know, I think the thing that was throwing me off yesterday is that Swift, our normal Swift code is very, very much procedural, imperative. You know, it's just a list of instructions, whereas SwiftUI is declarative. So it really is switching from thinking in instructions and sequences, linear timelines, versus now declarative, just describing what it should look like. Compose a custom view by combining built-in views that SwiftUI provides with other custom views that you create in your view's body, computed property. Okay, makes sense. Configure views using the view modifiers that SwiftUI provides. Yeah, modifiers are cool. Or by defining your own view modifiers using the view modifier protocol and the modifier method. Yep. Okay, so this is a view. It has the code, the config, and I guess that's what it's telling us. But yeah, no, this makes sense. I mean, we saw this yesterday, so main takeaway is the view as an object is our main building block, the lowest primitive in SwiftUI. And we just stack mini views to compose more and more complex views. And we use modifiers to change the data and the content inside the views. And there's many that are built in. We can also make our own. Okay, so now, whoops. Maybe I'll have to close all this stuff for now. Yeah. Instead, begin your journey by delving into the declaring a custom view article. Okay, now we're going that way. Let's see. Yes. Declaring a custom view. Define views and assemble them into a view hierarchy. Oh yeah, this is fantastic. Look at these examples. That's perfect. SwiftUI offers a declarative approach to user interface design. With a traditional imperative approach, the burden is on your controller code not only to instantiate, layout, and configure views, but also to continually make updates as conditions change. And just for the uninitiated, controller referring to the MVC, if you've ever heard of that. Mary, Victor, Charlie, model view controller. It's just a popular architecture for many apps, but predominantly web apps is where you'll hear it referred to. But you can do MVC with anything. So, but you have your model, which is your effectively your schema, your data layout, be it in SQL or if you're using, if you prefer to do that in types within the code itself, you can do it that way. Then you have the view, which is like your declarative, the HTML, the CSS, so what actually formats and makes it pretty. And then the controller is in charge of effectively everything else, like when things can run, in what order, authorization, all that stuff. It's the gatekeeper telling. It's really the brain, like it's where all your business logic is effectively. Okay, continually make updates in contrast. Where was I? Okay, the burden is on your controller code not only to instantiate, layout, and configure views, but also to continually make updates as conditions change. In contrast with the declarative approach, you create a lightweight description of your user interface by declaring views in a hierarchy that mirrors the desired layout of your interface. SwiftUI then manages drawing and updating these views in response to events like user input or state changes. Yep, beautiful. All right, so what is this telling me here? Actually, I'm going to go ahead and save that. Okay, we have a V stack, a vertical stack with text, hello world, with a modifier to the font, and more text. Glad to meet you. And then here's the output. Okay, yeah. Oh, I see. Hello world. Make it a title font, and so it's bigger. Okay, I got you. SwiftUI provides tools for defining and configuring the views in your user interface. You compose custom views out of built-in views that SwiftUI provides, plus other composite views that you've already defined. You configure these views with view modifiers and connect them to your data model. You then place your custom views within your app's view hierarchy. Right, we saw that yesterday with the whole content window, Dylan and Bob. Conform to the view protocol. Declaring a custom view type by defining a structure that conforms to the view protocol. Okay. Like other Swift protocols, the view protocol provides a blueprint for functionality. In this case, the behavior of an element that SwiftUI draws on screen. Okay. Conformance to the protocol comes with both requirements that a view must fulfill and functionality that the protocol provides. After you fulfill the requirements, you can insert your custom view into a view hierarchy so that it becomes part of your app's user interface. Right. So far we've not read anything that we didn't do yesterday through that sample chapter. Declare a body. The view protocol's main requirement is that conforming types must define a body computed property. The view protocol's main requirement is that conforming types must define a body computed property. So if our body in any of our custom conforming views, and this is so we have a mutable variable called body, and then we learned, of course, that this sum keyword with a protocol, it's what they call opaque types. So this is not quite a type declaration, but can be used as one because it's like saying, I don't necessarily know what the type will be, but it's going to conform to the view protocol. So the behavior can still be deterministic, and you can change your code without having to worry about something breaking just on that basis alone of conforming to the view protocol, which is the genius of protocols. So I've really enjoyed that part of that, and the extensions I think is, and enums being able to compute properties. Yeah, that's hot shit right there. in a good way. SwiftUI reads the value of this property anytime it needs to update the view. SwiftUI reads the... Oh, right. Yeah, so it's always going to process the trailing closure there anytime it's invalidated and then rebuilt. So we learned that yesterday too. That was a good example. And it needs to update the view, which can happen repeatedly during the life of the view, typically in response to user input or system events. Yeah. So basically reactivity, if you've ever used signals in web dev or something similar to it. Kind of like I keep forgetting the name of it, but it's very similar to how SwiftUI uses the two-way bind. Oh, Svelte is what I'm thinking of. It actually reminded me a lot of Svelte. Svelte is cool. I like Svelte a lot. The value that the view returns is an element. Is this where I was? Typically, yeah, okay. The value that the view returns is an element that SwiftUI draws on screen. Yeah, so the view type is always just, it's taking something and it's always trying to render something, which is something I need to remember. So anytime there's a view there, I need to remember there's a implicit return, which would be a re-render of the value. And not seeing that return word is kind of throwing me, but yeah, just have to remember that. So you're always getting something back when you get to the end of the scope, effectively. The views protocol's secondary requirement is that conforming types must indicate an associated type. What does that mean, right? Is that conforming types must indicate an associated type, which was I'm trying to think of what that. Hold on. Associated. This is another great little app. Really enjoy. There's just so many good examples here. All programming languages, not just Swift, but okay, I can't zoom in. That's cool, really. But this is what it looks like. It's probably hard to see, but it's probably bigger. See, protocol stack. And associated type. So that's the actual keyword, and then item type is the example here. The way that can really be anything. This here, so usually we would see it like in the Big Nerd Ranch, we saw it as like element, which just means this has to be some concrete type. Or if you did like, if you wanted it to be an optional, you would say associated type element. So element can be replaced with literally anything. It just would have to be an optional. So it's a placeholder for some concrete type, in effect. So that's associated types. And for the view protocol secondary requirement is that conforming types must indicate an associated type for the body property. However, you don't make an explicit declaration. Instead, you declare the body property as an opaque type using some view syntax. Yeah, some view. So those two, yeah. Syntax to indicate that the body's type conforms to view. The exact type depends on the body's content, which varies as you edit the body during development. Swift infers the exact type automatically. Yeah, good old compiler magic. Assemble the view's content. Try not to yawn. I'm not tired. Assemble the view's content. Describe your view's appearance by adding content to the view's body property. Describe your view's appearance by adding content to the view's body property. So inside the scope here. So this would be actually what's rendered, and that's what they got here. Straightforward enough. Inside the body, Right, well, there's custom views. For example, you can create a body that draws the string hello world using the built-in text view. Oh, so that's a type of view. Okay. Okay. In addition to views for specific kinds of content, controls, and indicators like text, toggle, and progress view, SwiftUI also provides built-in views that you can use to arrange other views. For example, you can vertically stack two text views using a VStack. Ah, okay. I mean, that's really simple. That's fantastic. Yeah. Okay, so struct my view. So this is a custom view, conforms to view. Then inside the body, in order to conform to the view protocol, we need the body variable with the opaque type of view. And then we wrap the two text things in this VStack scope here and just list them. Don't even got a comma separate them. And that's what it would render. Yeah, that's nice. Views that take multiple input child views, like the stack in the example above, typically do so using a closure marked with the view builder attribute. Why do I keep wanting on? This enables a multiple statement closure that doesn't require additional syntax at the call site. You only need to list the input views in succession. For examples of views that contain other views, see layout fundamentals. Okay, we'll refrain from clicking off, but wait, so views that take multiple input child views, like the example above, typically do so using a closure marked with the view builder attribute. Yeah, I mean, I just get annoyed sometimes with when they. It's like, why mention it at all if you're not going to show me? Like, hey, here's the thing, but most people do it this other way. Go read this other article. All right, brother. Configure views with modifiers. To configure the views in your view's body, you apply view modifiers. A modifier is nothing more than a method called on a particular view. To configure the views in your view's body, you apply view modifiers. A modifier is nothing more than a method called on a particular view. Okay, so yeah, modifier is a method. Since a view is a type, methods are just functions associated with types. The method returns a new, altered view that effectively takes the place of the original in the view hierarchy. SwiftUI extends the view protocol with a large set of methods for this purpose. All view protocol conformers, both built-in and custom views, have access to these methods that alter the behavior of a view in some way. For example, you can change the font of a text view by applying the font modifier. All right, so we saw this yesterday, so that's pretty cool. Very simple. So just beneath the view, we have the little dot modifier. Dot because we're accessing it inside the text type that it's modifying. There was one thing I wanted to X. What did that do? I'm gonna save it for my Halo stream, but I got more to say about this. This WNBA is just killing me, dude. How these women are so they're embarrassing themselves. That's crazy. Anyway, for example, you can change the font. Yeah, okay, so we saw that. For more information about how view modifiers work and how to use them on your views, see configuring views. Man, there's so much stuff. All right, manage data. Wait, I want to go back to this, or I wanted to ask before I got distracted. I canceled my OpenAI subscription to use Gemini because it's the same price, 20 bucks a month for the top thingamabob, but Gemini has like a way bigger context window, which really isn't the main point, but the true main point is you also get 2 terabytes for your Google account for Google One rolled into it, which is normally $20 anyway. So now you get the advanced, pro version of Gemini and 2 terabytes of storage, Google Drive. Sign me up, brother. All right, yeah. So anyway, just FYI, in case anyone's shopping around. But yeah, what was I gonna ask? Oh, yeah, in SwiftUI, is white space indentation used for scope? I don't think so, but I think it's just formatting, but just to be sure. Okay, no. All right, good enough, brother. All right, so okay, so then what we were looking at is just convention, but could be over here or over here, maybe even to the side, who knows. But indentation is optional. For more information about how these work, okay, we read that. Manage data. To supply inputs to your views, add properties. To supply inputs to your views, add properties. For example, you can make the font of the Hello World string configurable. All right, so you have your view. Then we have hello font of type font. Okay. And before it was what? Font title. Then modify the, whatever they pass in. Okay. If an input value changes, SwiftUI notices the change and redraws only the affected parts of your interface. This might involve reinitializing your entire view, but SwiftUI manages that for you. Because the system may reinitialize a view at any time, it is important to avoid doing any significant work in your view's initialization code. It's often best to omit an explicit initializer, as in the example above. Okay, so meaning we don't write our own init thingamabob, allowing Swift to synthesize a member-wise initializer instead. And so the member-wise initializer just meant that implicitly, if we don't write an actual, like inside this, we could do like init and then only name, what would it be, like hello font or whatever, as a way to initialize an instance of this view. But if we just leave out and don't define any custom init, or rather initializer, then the member-wise initializer that the compiler will build for you is, like, let's say we had another let something equal, or let's say we had 2 of them. So the compiler would look at this view and then implicitly just create the member-wise initializer, which would mean that anytime we initialize an instance of my view, we have to provide values for hello font and for something. So for each property that you got in there, it's going to force you to give starting values anytime you try to initialize a new instance. So that's what they're saying there. Let's see, refrigerator. If an info value changes, SwiftUI notices. Oh, right. Member-wise, SwiftUI provides many tools to help you manage your app's data under these constraints, as described in model data. I'll save that link, brother. Oh, why can't I? Okay, I guess that one's special. Let me reload it. With modifiers. There we go. Add your view to the view hierarchy. After you define a view, you can incorporate it in other views, just like you do with built-in views. You add your view by declaring it at the point in the hierarchy at which you want to, in which you want it to appear. For example, you could put my view in your app's Oh, in your app's content view, which Xcode creates automatically as the root of a new app. Yeah, so I think, yeah. Real quick, why don't we just look at all of the types of views? If does it break them out that way? Let's see, other layouts, layout fundamentals. It doesn't look like it has a specific section, or maybe I'm not understanding, but that's why I want to get just a list of like what exactly are, yeah, I got it. Okay. How, or no, what are the SwiftUI built-in views? God damn, holy hell. So those are, okay, those are all considered views. Like literally all of them. Let's see, is that true? Scroll view. Image, shape, group, frame, toolbar, toggle. Yeah, it. Okay, so these are all views. So even like little widgets and whatnot, they're referring to as views. Okay. Well then, I mean, you can see all of the different built-in ones. Maybe not read them, but all along the left-hand side, these are all different. Okay, so that's helpful. So split view, tab view. Let's see. Views are the building blocks that you use to declare your apps. So I guess like to me, the only other exposure I've had to that term views are like SQL views, which are like precompiled SQL queries. So they're not actual data tables. They're just predefined queries that you can call on, and then it'll give you that the output of that query on demand. It's like a virtual table that you can call on anytime. Very different here. So in this case, a view isn't even necessarily like a. Initially, I was thinking it was more like a, like relative to the canvas in web dev, which would hold all of your visual elements, or the DOM rather, I should say the DOM, maybe not the canvas, but the DOM. But this definition here, they're saying view is more like it equates more to a component. If you've ever written any React code or any of the like Vue or Svelte, they all use that term, but you know, just a little piece of, well, maybe not, because components are meant to, they're like self-contained pieces. These aren't necessarily that. Or maybe they are. So it's one of those two. It's either at the component level, I can either equate it to the component level, or just an HTML element itself, which actually I think kind of sounds like the more appropriate analogy, given that even you know, something like a toolbar is a view, an alert, a popover, you know, that kind of stuff. Yeah. But either way, lower level than the entire view itself. So that's something, that's a thing to remember. All right, so declaring. Okay, and we got to the end here. All right, now we can go back. by delving into declaring a custom view article. So we read that. Reinforcing the foundational concepts you've likely observed passively from the SwiftUI tutorials mentioned in the previous module. As a general rule, when I link entire sections, as I did above, okay, we read that. I suggest refraining. Okay, we got there. View protocol and its associated type. The view. Oh. After reading the article and looking at the Xcode template code, you can see that declaring a custom view is relatively straightforward. However, a few elements merit attention. You may not have encountered these Swift features yet, potentially causing confusion. Any custom view must conform to the view protocol. Protocols define requirements that conforming types must fulfill, as detailed in the initial sections of the protocols page in the Swift programming guide. Right, and that's that body computed property that we saw. If you are unfamiliar with protocols, I recommend reading protocol syntax. We're not doing that because we already did that. Like any other symbol, the view protocol has a documentation page listing its requirements. I will save that. Topics. Implementing a custom view. So these are the two requirements for the view protocol. So we need mutable variable called body. Ours was self.body. The content and behavior of the view. Associated type, body view. Okay. The type of view representing the body of this view. The type of view. Oh, yeah. The complexity arises in the body computed property, which has a return type of self.body, which the big self we learned was just, it's relative to protocols, and it's just a way to refer to itself as the type, or whatever the type is in that instance. So whatever the concrete type turns out to be, because initially we're just using that opaque type, which just says we don't know what type it is yet, but it'll conform to the view protocol either way. Okay, the complexity arises in the body computed property, which has a return type of self.body, which is not a standard Swift type. The crucial aspect lies in the following declaration on the page, the body associated type. You won't find an explanation in the protocol page I linked above, as associated types are essentially generics. Yeah. However, delving into the relative section in the Swift programming guide is unnecessary. What is vital here is that the body associated type must also adhere to the view protocol. Yep. Since the body computed property has a body type, it must return a view. Oh, since the body, like little body, as in the variable, has a body type, it must return a view. Okay, that makes more sense. So little body, self.body. Oops, I didn't want to do that. So it must return a view type. Because by saying self, you're referring to the thing that is defining you, which is the view protocol. And then whatever type is in the body, it has to conform to the view protocol. Okay. The requirement is denoted by the some view return type in the actual implementation of the body computed property, such as in the content view type showcased earlier. If you're curious, this represents an opaque type. Nonetheless, comprehending the intricacies of opaque types isn't mandatory. Simply remember that whenever you want to use a protocol as a return type, you have to prefix it with the some keyword. Yeah, it's a good way to sum it up. Matter of fact, actually, this was all pretty good. So I'm going to hold on to this. The text really won't help me, so I need probably this. Oh shit, it's taking the whole. Okay, well. Yeah, that's okay. Just never mind. I'm backing out. I don't want to save that. I don't want to save that. All right, let's just go back to where I was. We'll just take this instead. There we go. All right. Generating Xcode previews with the preview macro. Xcode previews constitute a fundamental aspect of SwiftUI development. The SwiftUI documentation includes a dedicated section covering previews. So let's read through that. Previews in Xcode. Generate dynamic, interactive previews of your custom views. Overview. When you create a custom view with SwiftUI, Xcode can display a preview of the view's content that stays up to date as you make changes to the view's code. And I opened his little, what's called, example app. So there should be one here. Yeah, so just, they're referring to, there should be a preview, this thing here. This hash preview. So if we were to comment this out, it should go away. But if you want to see your code, kind of like the HMR hot module reloading. There we go. I think some of them call it hot code reloading too, but it just means you can see your changes in real time. But if you comment that out, it goes away. But if you were just to write it into your editor, then it'll recognize that and automatically open the preview window for you. All right, so that's what they're talking about there. And then, preview body. You use one of the preview macros, like preview body, to tell Xcode what to display. Xcode shows the preview in a canvas beside your code. Matter of fact, I meant to change this. I don't want to see it at the bottom anymore. Well, and we'll get there. Never mind. I forget about the grammars. That's why I did that. Okay. Different preview macros enable different kinds of config. For example, you can add traits that affect the preview's appearance using the preview traits body macro, or add custom viewpoints for preview using the preview traits body cameras. Goddamn, macro. You can also check how your view behaves inside a specific scene type. For example, in Vision OS, you can preview immersion style traits body macro to preview your view inside an immersive space. Are you fucking kidding me? That's amazing. Yeah, that's really cool. If you haven't seen that yet, we're going to look at it. We'll look at the end of the stream. I need to have let me write it right here. Yeah, preview Vision OS, Vision OS. You got to see it. It's honestly probably like 30% of the reason why I also chose Swift, because I mean, I know they're not that popular now, but history's told us if Apple throws down some hardware on something, any domain, you know, it's time to take the shit seriously. So you know, Meta did it. They came out with the Oculus thing. I was like, yeah, kind of looks like Wii U graphics. Not really sold, brother. But then Apple did it. I'm like, okay, it would be cool to be able to write apps for this thing. But yeah, if you haven't seen what the interface looks like on the Vision Pro, we'll take a look at the end of the stream. But it's pretty sick already what it can do. It's just very limited hardware, and both from a hardware and software perspective. But the few things it can do now is pretty impressive, and it'll just get better. If you can imagine, like, remember how mind-blowing, I can remember when I got my first iPhone, and like going to a normal website on a phone, and there wasn't even all this bullshit about mobile sites or whatever. So whatever site you went to on the iPhone, of course, you know, in landscape, you just got the full desktop view. I could not believe it. I just couldn't believe it. I remember that feeling though. Now we look at them like, man, that phone's fucking trash. But you know, at that time, that was some hot shit. So I have no reason to believe that you know, Vision OS won't do the same, because nothing else has missed. Everything that Apple TV, Apple Watch, what else is that? The iPad. No one was taking tablets seriously. Now the iPad Pro is like the de facto shit. Mine's right here, you know. So yeah, I'll be ready. You typically rely on preview macros to create previews in your code. However, if you can't get the behavior you need using a preview macro, you can use the preview provider protocol. If you can't get the behavior you need using a preview macro, you can use the preview provider protocol and its associated supporting types to define and configure a preview. Okay. I wish it showed. I don't know why these are written with the hash thingy. SwiftUI. Preview context. I'll just ask Gemini real quick. What is the live preview, Xcode? Is pound preview. I just want to know what to consider it. A compiler. So it's not a compiler control statement, even though we write some with that hashtag or that pound ahead of it. It's not a compiler control statement. It's a special feature provided by Xcode. Okay. And the SwiftUI framework to facilitate live previews. Our directives that instruct the compiler on how to handle specific aspects. Preview is solely for creating visuals previews in Xcode. Okay. So that's it's only in dev. That's its only application. Okay. Makes sense. Scope. Preview only impacts the Xcode preview environment. Near compilation. Previews used by Xcode. Okay. Different syntax. Oh, I see. That's a good point. Okay. So it really is different syntax. Because the compiler one, now that they say that, was like an if, kind of like bash. Have you ever seen those if loops or end if, end if, whatever? But yeah, it was like if debug. So some predicate afterwards. Okay. All right. Okay, so it's a macro. However, you might notice a dedicated section covering previews. Oh, and that's when we hopped over to read that. Okay. There, start with the documentation for the preview provider protocol, which parallels the view protocol for views. Okay. Preview provider. I don't think we ever ended up covering what main actor meant, but we did see it in Big Nerd, so we'll leave it for now. But okay, preview provider, and it's of type preview provider, or adheres to. That's okay. Well, I mean, we learned that the underbar is to indicate to the user, us in this case, because we're a user of the framework, that it's private, effectively. So like we wouldn't, I think in SwiftUI it's closed source, so we wouldn't even be able to see what the implementation is. We just have the interface. All right, important. You can use this protocol to define a preview manually, but you typically use a preview macro like preview body instead. Okay, that's what I want to ask it. So what's the difference? Because they keep saying that, but we don't see it in the example. Gemini. What is the difference between and using right? That's what he had. Yeah, preview body. Okay, difference between using preview with environment modifiers and the preview provider protocol. So preview, the hash preview with environment modifiers, which we'll call it a macro since that's what he called it. So the macro preview. Primarily used for simple, quick previews. Okay. It's a convenient way to visualize a single view within the Xcode canvas. Okay. Environment injection. Environment modifiers like .environment are ideal for quickly injecting sample data or specific environment values into the previewed view. That's pretty sick. Yeah. Cool. Limitations. Lacks the flexibility for complex preview scenarios, not designed for creating multiple diverse previews. Can't control the preview's layout or size. Testing different states. Preview protocol, blah, blah, blah. So now the preview protocol provides a structured way to create multiple views with different configs. Okay, so quick and dirty versus a more specific one. Imagine a content view displaying a shopping cart. Here's how you could use both approaches. So preview, and that wraps the content view and then any modifiers. Or we can define a struct that conforms to preview provider. And then effectively just writing our own. Okay. Okay. I guess my only other question is, are they both macros and okay, well, he calls it a macro. Gemini says it's not a macro. We will just move on and just know what it does. How about that? So no one wants to get it straight. All right. I'm sure he's adapting the concept to work here, so that's fine. That's well received. All right, as mentioned earlier, Swift macros generate code before the compiler's execution. Xcode enables direct macro expansion within the editor. Control click on any macro and choose expand macro for the contextual menu. Really? Wait, no. Option click on any macro. Yeah. Option click. Option click any macro and choose expand macro. Expanding the preview macro reveals a structure with several numbers. What the fuck? I don't get that. Why don't I get that? This here. Option click. Control click. Oh, it's control click for me. Okay, expand macro. This is cool. Okay, so the OS versions it's available in, whatever the hell that is. The registry, developer tool support. String int. Make preview throws. Yeah, not sure. After the first line, didn't really know what I was reading, but that's okay. But that's cool. So that's that's good to know. So you can expand it. On mine, it was control. Yours might be option. Yeah, never know. Try both. All right, so let's see. Expand macro, yeah. Reveals a structure with several members. Yep. Okay, we saw that. The structure doesn't conform to the preview provider protocol, but to the preview registry protocol in the developer tools support framework. Oh boy. The documentation for this protocol is limited because it is intended solely for use by the preview macro. I present this information so that you can see that there's nothing extraordinary about this form of preview. They remain basic Swift structures. Yep. All you need to know is that the preview macro is recommended whenever feasible. You should resort to Swift structures conforming to the preview provider protocol only when supporting older platforms. Okay. Yeah, it's always interesting because, I mean, like I said, I mean, if we take the man at his word, and I do, he's been doing it for 10 years. The AI says, it mentions nothing about don't use one over the other, just use the best tool for the job kind of a thing. If you want simple, dirty preview, if you want custom, use, define it yourself versus his opinion on things. So it's just always interesting. But I mean, I think maybe I side with the UI a bit on that one just because it didn't look. Maybe he's saying that because he did say he's assuming we don't know the language particularly well. So maybe that would make sense actually. Yeah, okay, configuring text and images and reading documentation with generic types. Configuring text and images. I assume at some point we'll get into Xcode, but yeah, because he did provide a sample project, but just hadn't mentioned it yet. All right, configuring text and images and reading documentation with generic types. When you begin creating apps in Xcode, its template code introduces several SwiftUI concepts at once. Yep. So custom views, the body, opaque types, nesting views, modifiers, all different things that we see here. This short code snippet demonstrates the use of multiple SwiftUI concepts simultaneously. Standard views like text and image, configuration using view modifiers, basic layout through stacks, yep, and view composition through view builders. Oh, okay, wait a minute. So that's one thing that I didn't really register before, but does this thing have a section for builders? Images. Doesn't seem like it, so we'll just ask what are the SwiftUI view builders? Okay, I mean, those make sense, right? I mean, those are all effectively layouts, ways to arrange things. So that's pretty straightforward. So your V stack, H stacks for horizontal, Z stack for like a, more or less works like a pile of papers. You know, whatever's in front will be at the forefront, but it'll still show things in the background if it's offset. Lazy loading grid makes sense. List for each a form. Yeah, group used together without affecting the layout. Oh, that's cool. Other view builders. Tuple view. Conditionally, it displays one view or another based on a Boolean value. Oh, nice. Conditional content. I'll remember that one. Section. Tab view. In addition to these, you can create your own custom view builders to encapsulate the specific layout or view creation logic. I want to look at that one closer. Custom view builder. Look at that. You can write your own. It's just a struct, labeled content. So we just name that whatever. It's a generic, so a type, whatever type, but it must conform to view. And then the struct itself will conform to view. Then we need a label, property, content property, and the body. That's really not that bad. I mean, hell, you'll have a harder time writing a web page, that's for sure. All right, cool. So, shoot, let me save that. Can I export to Replit? Oh, that's cool. Although I canceled my Replit because I think it's good through the end of the year, but I don't know. Too fucking slow, honestly. All right, so get here. Let's go back. Fortunately, these concepts are relatively easy to grasp due to progressive disclosure. The hell is that? Just throwing the terms out. What? In Swift context. What is... I think it's them bragging on their own language effectively, as I recall, which is, then that's fine, but it's a Swift thing, not necessarily like a programming at large concept. Is the design principle? Yeah, there you go. Okay, that's fine. Yeah, close enough, or says enough. However, the documentation can sometimes be challenging to navigate. We'll take this opportunity to delve deeper into some of SwiftUI's elements that might confuse you. Great. Configuring views using view modifiers. The article on declaring custom views I shared in the previous lesson partially covers the concepts listed above and briefly mentions the use of view modifiers. Following this, read the configuring views article in the View Fundamentals section for a more detailed exploration of view modifiers. We will use text and images extensively when building our example app. Below, you can find a primer on these topics. Maybe before or after I read this? Following this, more detailed. Okay, so we might come back and read that. Pow. Like we just kind of did, though. Symbol. Oh, no, maybe we didn't. Okay, so we'll read that after in the View Fundamentals section. Configuring views. Yeah, okay. Configuring text attributes like size, font, and appearance. Text is the most fundamental element of any app. Okay. Start by exploring the documentation page for the text type. This will offer insight into how to configure text in your apps. In the text input and output section, you will find additional information about text in your apps. Feel free to peruse its sections, which lists several handy view modifiers when configuring text. For example, Under setting a font, you find several view modifiers affecting your text font. And applying custom fonts to text article is helpful if you want to use a font not included in the iOS system fonts. Under controlling text style, you also find other valuable modifiers to alter the visual appearance of text in your apps. The monospace digit modifier is interesting when you want to align text containing numbers. Ooh. Yeah, I want to look at that. It is also helpful to avoid text that constantly changes size in apps displaying timers and countdowns. Finally, at the bottom of the page, under localizing text, you find the preparing views for localization article and some view modifiers valuable when displaying text in different languages. I always wondered about that. That's complicated. Resizing and tiling images to fit them in an app's interface. Actually, well, let's go read. How much is left here? No, yeah, we better go. Let's do the reading first. Configuring views. All right, configuring views. Adjust the characteristics of a view by applying view modifiers. In SwiftUI, you assemble views into a hierarchy that describe your app's user interface. To help you customize the appearance and behavior of your app's views, you use view modifiers. For example, you can use modifiers to add accessibility features to a view, adjust a view's styling, layout, and other appearance characteristics, respond to events like copy paste. Oh, cool. Yeah, conditionally present modal views like popovers, configure supporting views like toolbars. Okay, all through modifiers. Because view modifiers are Swift methods with behavior provided by the view protocol, you can apply them to any type that conforms to the view protocol. That includes built-in views like text, image, and button, as well as views that you define. Configure a view with a modifier. Like other Swift methods, a modifier operates on an instance, a view of some kind in this case, and can optionally take input parameters. For example, you can apply the foreground color modifier to set the color of a text view. So the text and then the dot foreground color and then dot red. Modifiers return a view that wraps the original view and replaces it in the view hierarchy. You can think of the two lines in the example above as resolving to a single view that displays red text. Yeah. While the code above follows the rules of Swift, the code structure might be unfamiliar for developers new to SwiftUI. SwiftUI uses a declarative approach, where you declare and configure a view at the point in your code that corresponds to the view's position in the view hierarchy. Yeah. For more information, see declaring a custom view, which I believe we looked at that. Chain modifiers. Wait, I don't think we're supposed to. Oh no, we are. Yeah. Chain modifiers to achieve complex effects. You commonly chain modifiers, each wrapping the result of the previous one, by calling them one after the other. For example, you can wrap a text view in an invisible box with a given width using the frame width height alignment modifier to influence its layout, and then use the border width modifier to draw an outline around that. But okay, I guess you don't have to pass it all three, so we just give it the frame width of 100, and then that gets wrapped with the border of gray. The order in which you apply modifiers matters. For example, the border that results from the code above outlines the full width of the frame. Okay. Oh, so if we did border first, it would just be around the text and not the frame. By specifying the frame modifier after the border modifier, SwiftUI applies the border only to the text view, which never takes more space than it needs to render its contents. Yeah. Wrapping that view in an invisible one with a fixed 100 point width affects the layout of the composite view, but has no effect on the border. Oh, so we apply the frame and then that gets the gray, but here it's just a border around the text itself, and then the frame, which we can't see because there's no color. Wrapping that view in an invisible one with a fixed 100 point width affects the layout of the composite view, but has no effect on the border. Configure child views. You can apply any view modifier defined by the view protocol to any concrete view, even when the modifier doesn't have an immediate effect on its target view. The effects of a modifier propagate to child views that don't explicitly override the modifier. Yeah, so if you've ever worked with CSS, it's the same thing. There's always going to be a, hence the name, cascading style sheet. So it's always going to cascade down, not up, but it'll always cascade down unless told otherwise. For example, a VStack. Ah, shit. Hold on, I gotta pee actually. Ooh, getting all stiff, brother. Actually, we'll take a little breather here. Nature calls, and I must answer. Oops. Oops. What's going on? Oh, there we go. All right, BRB. What time is it? 2 CST. Wait, that's optimistic. 2:32. How about that? CST. All right, be right back. Hot dog. Yeah. All right. We're back early, early, early. So early. All right, where were we? Um, Configuring views. A lot of ceremony today. Wait, do we finish reading this? Maybe not. You can apply any view modifier defined in the view protocol. I don't think we did. Yeah, no. Configure child views. You can apply any view modifier defined by the view protocol to any concrete view, even when the modifier doesn't have an immediate effect on its target view. The effects of a modifier propagate to child views that don't explicitly override the modifier. Right, yeah, this is where we're at. For example, a VStack instance on its own acts only to vertically stack other views. It doesn't have any text to display. Therefore, applying a font modifier to the stack has no effect on the stack. yet the font modifier does apply to any of the stack's child views. I see. Some of which might display text. You can, however, locally override the stack's modifier by adding another to a specific child view. Okay. Oh, I see. So if they both have a font modifier, it'll take the one from the parent because this one is applied to the V stack since it's at the end of its scope. So it would apply to anything inside. But since this particular text view has its own font modifier, then title will apply to title view and body will apply to these two. Okay. I mean, I dig it, brother. That's pretty straightforward. Use view specific modifiers. While many view types rely on standard view modifiers, for customization and control, some views do define modifiers that are specific to that view type. Okay. That view type. You can't use such a modifier. I'm not tired. You're tired. You can't use such a modifier on anything but the appropriate kind of view. For example, text defines the bold modifier as a convenience for adding a bold effect to the view's text. I see. So yeah, so there's certain modifiers that are only applicable directly on a given type. And that makes sense. So there's all-encompassing ones and then, or rather shared ones, and then ones that are scoped to the particular type. While you can use font on any view because it is part of the view protocol, you can use bold only on text views. As a result, you can't use it on a container view. Okay. You also can't use it on a text view after applying another general modifier because general modifiers return an opaque type. Okay. For example, the return value from the padding modifier isn't text, but rather an opaque result type that can't take a bold modifier. And it can't take the bold modifier because the opaque type has the potential to return a type that is not text, and bold only belongs to text is what we learned. So that makes sense. Text, hello world, padding, bold. Can't do that because padding returns an opaque type, not a text type. Okay. Instead, apply the bold modifier directly to the text view and then add the padding. Nice. It's a nice, simple solution. Okay. Yeah, I mean, that was a really good article. Thanks, Apple. All right, so we will use, section 4. We'll use text and images extensively when building our example app. Below, you can find a primer on these topics. Configuring text attributes like size, font, and appearance. Text is, well, we read this part. And the text output. Oh yeah, we read that too. Your texture app. Feel free to peruse its sections. Nah, we won't go there just yet, but resizing and tiling images to fit them in an app's interface. Yeah, okay, we will do this. For images, refer to the images section, dive into the documentation page for the image type and the fitting images into available space article for the image type. I wonder why it's supposed to always open any tab. The hell, man. Okay, so what I wanted to do was this. There we go. Add images and symbols to your app's user interface. was hoping I could, I guess I can't do that. Okay, I guess that'll work. All right, so images, and it wanted me to look at, oops. Documentation page for the image type. I wish I could swap this. Then it would be perfect. Damn it. Configuring. Can't copy from here. Oh well. Let me just find it here. So the image type. Make sure that's the same. Yeah, same thing. Okay. Overview. Use an image instance when you want to add images in your SwiftUI app. You can create images from many sources. Image files in your app's asset library or bundle. Supported types include PNG, JPEG, HEIC, and more. Instances of platform-specific images types like UI image and NS image, which we learned is old school. Next step stands for next step, NS. A bitmap stored in a core graphics CGI image instance. Cool. System graphics from the SF symbols set. Okay. The following example shows how to load an image from the app's asset library or bundle and scale it to fit within its container. Image. And the argument is, I guess, the name of the file. We modify it with resizable and aspect ratio. So we force it to fit the container. And then we label or throw down some text, water wheel. Cool. Wait, so this is, yeah, okay. You can use methods on the image type as well as standard view modifiers to adjust the size of the image to fit your app's interface. Here, the image types resizable cap inserts with, cap insets, not inserts, cap insets as the first argument, resizing mode as the second method, scales the image to fit the current view. Then the aspect ratio, content mode, view modifier adjusts the resizing behavior to maintain the image's original aspect ratio. Oh, okay, so what did it do? Just fit. That's it, aspect ratio, and we only pass it content mode. Okay. The content mode, view modifier adjusts this resizing behavior to maintain the image's original aspect ratio, rather than scaling the X and Y axes independently to fill all four sides of the view. Okay. The article fitting images into available space shows how to apply scaling. Is that what yeah, that's what they call it. It shows how to apply scaling, clipping, and titling to image instances of different sizes. An image is a late binding token. The system resolves its actual value only when it's about to use the image in an environment. That's interesting. An image is a late binding token. It only resolves the actual value when it's about to use the image. Making images. Oh, I guess that lazy loading is kind of a late binding token. How does it see thumbnails then? Or maybe that's what they consider. I don't know. Because I know on the web, they have a method of, like in the background, you can only, or you can only have it load, I shouldn't say only. To increase performance, you can start your web page with just a piece of the total page, and then as I'm scrolling, just like I'm scrolling here, if things are coming into view, it can sense that and it'll start to do whatever computing it needs to do to make that content ready. So you're kind of chopping up the work required to generate the content of an entire page, and you're only generating what's in the viewing window for the user. So I don't know if that is similar to that, but nothing else is really resonating. Okay, making images accessible. To use an image as a control, use one of the initializers that takes a label parameter. This allows the system's accessibility frameworks to use the label as the name of the control for users who use features like voiceover. Oh, right, yeah. For images that are only present for aesthetic reasons, use an initializer with the decorative. Does that look funny? The decorative parameter. The accessibility systems ignore these images. Oh, okay. Topics, creating an image. Init. Pass it a string. Name the bundle parameter, and then it has to be of type optional bundle. Creates a labeled image that you can use as content for controls. And those have to be optionals because of the fact that it doesn't, or I guess because it might fail. I guess that makes sense because like if you're using a CDN or something, that server goes down, those images aren't available. And that's when you get that ugly little, like on Google, it's like, oh snap, something went wrong. I don't know what it says on Apple, but when something can't load, y'all have all probably seen it. That little square face with like X's in his eyes. Okay, but where was that? There was an article. There we go. Fitting images into available space. Adjust the size and shape of images into your app's user interface by applying view modifiers. Overview. Image sizes vary widely from a single pixel PNG files to digital. I thought that said something else. Photography images with millions of pixels. Because device sizes also vary, apps commonly need to make runtime adjustments to image sizes so they fit within the visible user interface. SwiftUI provides modifiers to scale, clip, and transform images to fit your interface perfectly. Really? Because the device sizes also vary, apps commonly need to make runtime adjustments. Oh, yeah. Yeah, scale a large image to fit its container using resizing. Consider the image landscape underbar 4.jpg, a photograph with the dimensions 4032 by 3024, showing a water wheel, the surrounding building, and the sky above. Okay. That do be the image right there. And then the following example loads the image directly into an image view and then places it in a 3 by 400 point frame with a blue border. Okay, so we call the view, tell it what file, then we call this modifier frame, give it the frame dimensions and the alignment, top leading, and blue border. As seen in the following screenshot, the image data loads at full size into the view, so only the clouds from the upper left of the original image are visible. Because the image renders at full size, and the blue frame is smaller than the original image, the image displays beyond the area bounded by the frame. Yeah. Okay, to fix this, you need to apply two modifiers to the image. Resizable tells the image to tells the image view to adjust the image representation to match the size of the view. By default, this modifier scales the image by reducing the size of the larger images and enlarges images smaller than the view. By itself, this modifier scales each axis of the image independently. So so it has potential to be, Hall of Mirrors looking all goofy. Aspect ratio corrects this. Aspect ratio corrects. Maybe it's time to get off. Corrects the behavior where the image scaling is different for each axis. It corrects behavior where the image scaling is different for each axis. How does it know? That's pretty cool. This preserves the image's original aspect ratio using one of two strategies defined by the content mode enumeration. Oh, I guess that's how it knows. Content mode fit. Oh, duh. You see this in a lot of, I mean, if you've ever touched any editing app, really, any photo editing app or video editing. Yeah, so either fit the whole thing and accept some black lines, maybe. Or just fill. I guess, well, you could have, well, now fill shouldn't give you black lines, but it might not fit everything too. Scales the image to fit the view along one axis, possibly leaving empty space along the other. Yeah, on the X. Content mode fill scales the image to fill the entire view. Yeah. Okay. So image landscape we call resizable first, and then aspect ratio to drive the behavior with a fit directive. Then we modify the frame itself. So we want it to fit, and then we say here's the frame, so it has to fit inside a 3x400 and then a blue border, and voila. Okay, wait, so that's with fit, not fill. Okay, yeah. So it fit everything according to the X axis, but not the Y, obviously. Keep image data inside the view's bounds using clipping. Keep image data inside the view's bounds using clipping. If you use content mode.fill when scaling an image, a portion of an image may extend beyond the view's bounds, unless the view matches the image's aspect ratio exactly. The following example illustrates this problem. Okay, so now we're doing the same thing, but content mode is now fill instead of fit, and we get this with the blue representing our 3x400. Okay, to prevent this problem, add the clipped anti-alias modifier. This modifier simply cuts off excess image rendering at the bounding frame of the view. Cuts off excess image rendering at the bounding frame of the view. Okay, so the blue line, effectively. Optionally, you can add an anti-aliasing behavior to apply smoothing to the edges of the clipping rectangle. This parameter defaults to false. The following example shows the effect of adding clipping to the previous fill mode example. Okay, so all we changed was adding an additional modifier to the chain, and huzzah. Yeah, man. It's pretty nice. Use interpolation flags to adjust rendered image quality. How can I save? Oh, what would be a good way? I'm trying to think of a good way to save my... Probably just exactly like this. Yeah, we'll just do it like this. Shit. What section were we on? Well, I don't need that complete, but okay, so I just want to save this that way. Tomorrow, I remember where the hell I was. So here, then we will throw that bad boy on the board. And here, what is today? Today is 666. All right. So let's do a new little section over yonder. Pa-pa-pa. 6. Stretch that mug out. There you go. Whoops. And at some point we'll paste. Why is it so tiny? Good grief. Dude, why is it so little? I guess you can still kind of see it, but it's funny. There we go. That's a lot better. Let's just do... Get rid of that. All right, so that's where we will pick things up tomorrow. So per usual, y'all, thanks for tuning in. Go ahead and drop a follow if you haven't already. We'll be back tomorrow, 11 a.m. Wow, I keep saying that. I apologize for starting late. Tomorrow we'll start on time. Maybe. But we'll be on tomorrow. And per usual, also check out my stream, 9 p.m. every day unless said otherwise, on this same account if you're watching on X. 100 Days of Halo Ranked. So that'll be 9 p.m. Central every day. Take care of yourselves. There's a lot of reading today. It's not I mean, I'm learning stuff, but I know it's not as engaging as, you know, actual proper code samples, but there is an actual app that's associated with this course. So don't worry, we're going to start looking at code soon enough. But yeah, this has been helpful still. So I like it. I'm going to give the course so far, day 1 review, I'm going to give it an 8. I like it. I like its approach. All right, guys, take care of yourselves. We'll see you next time.